Greetings, Doctor and everyone. Today, we from Group 1 would like to present Row-echelon matrix REM, Row-reduced echelon matrix REM, and rank of a matrix in Chapter 7. Our group members are Ho Jin Yao, Go Chi-gun, and me, Wei Jingwei. So, without further delay, I would like to start by talking about Row-echelon matrix and Row-reduced echelon matrix REM. Okay, so for Row-echelon matrix, as you can see, they have the following property, which are they consist of at least a non-zero row, and followed by the leftmost non-zero entry in a row is 1. The third one will be the leading one in the lower row occurs further to the right than the leading one in the upper row. And the last of Row-echelon matrix will be if there are any row that consists entirely of 0, that they are grouped together at the bottom of the matrix. Moving on, for row-reduced echelon matrix, we'll have this additional property, which are each column that contains a leading one that has 0 everywhere else. And we will look at the example now. Okay, so for A, as you can see, and clearly this will be the row-echelon matrix because they have all non-zero and they are grouped together at the bottom of the matrix. So this will be REM. While for B, as you can see, this follows the property of the row-reduced echelon matrix, which has each column that contains a leading one that has 0 everywhere else. So this will be our REM. And for the third one, as you can see, and this also follows the property of row-reduced echelon matrix. So while for the last one, as you can see, clearly this is also similar to the question part of part A. So this follows the property of echelon matrix. Okay, so for now I will pass it on to Jin Yao to further explain about these two.
Hi everyone, I'm Ho Jun Yao. Now I will explain on the examples given in the note. Decide whether each of the following is a row echelon matrix REM, row reduced echelon matrix REM, or neither. So first we look at matrix A. Matrix A, this one is not a REM, as this one does not follow the properties number 3, which is the leading one in the lower row occurs further to the right than the leading one in the upper row. So this one you can see that in row number 2, the leading one occurs further to the left to the leading one of row number 1. So this one is not a REM, and since it's not a REM, it can't be a REM as well. So this one is neither REM nor REM. Then we look at matrix B. This one is not the REM as well, as you can see that the row consists of all zero entry located at the uppermost row in the matrix. So we can see that the properties, if there are any rows that consist entirely all zeros, then they are grouped together at the bottom of the matrix. So this one, since it located at the uppermost part, then it can't be REM. So this one is neither REM nor REM. Then matrix C. This one is not a REM as well. As you can see, leading one in row number 2 and number 3, they're located at the same column. So this one is not a REM. Then matrix D. Matrix D is not a REM as well. As you can see, the lowest row, the bottom row, you can see the leftmost non-zero entry is -1. It's not 1. So this one is not a REM as well. Then E, matrix E. Matrix E Okay, we check the properties one more time. Okay, the leftmost non-zero entry is 1 for every row. Yes. Then the leading one of the lower part exists further to the right to the leading one in the upper part. Yes. And the row consists of all zero entry located at the bottom. So this one is REM. Then we check whether it is a REM or not. So for this one to be RREM, the column contains leading one must have at least one zero entry in the column. So we can see that, okay, column number 1, the column consists of leading one. It has a zero entry. So first one fulfill. Then we look at the second leading one. It has a zero entry as well. So this one is a REM. Then matrix F. The leftmost non-zero entry is 1. Okay, the leftmost zero entry is 1. The leading one of the lower row occurs further to the right. Yes. The bottom part is all zero entry. Yes. The column consists leading one have at least one zero entry in the column. Yes. So this one is REM and REM. Then we look at matrix G. Okay. The leftmost non-zero entry is 1. The leading one occurs further to the right every column. Yes. Then so this is a REM. Then we check whether it is a REM. Okay. The column consists leading one has a non-zero entry. Yes. So this one is REM and REM. Then we look at matrix H. Matrix H. Okay. So the leftmost non-zero entry is 1. Okay. The leading one occurs further to the left. Further to the right. Yes. And so this one is REM. Then we check whether it's REM. So the column consists of leading one has at least a zero entry. So every column has a zero entry. So this one is REM. Then we check matrix J. Matrix J is very obvious. This is not a REM. As you can see, the leftmost non-zero entry for row number 1 is -1. It's not 1, so it is not a REM. And since it's not a REM, it can't be a REM. Then we look at matrix K. Matrix K. The leftmost non-zero entry is 1, correct? The leading one occurs further to the right for every row, yes. So this is a REM. Then we check whether it is a REM. So the row consists of leading one has at least a zero entry for the column. For column number 1, yes. Column number 3, yes, but it is not for column number 4. Column number 4, you can see that there is no zero entry for the entire column. So this one is a REM but not a REM. Okay, so that's all for this part.
Hi everyone, I'm Go Chakwan, and I will be going to explain on what is the rank of a matrix and the way to find the rank of a matrix. First, the rank of a matrix is the number of rows that is non-zero in the echelon matrix or reduced echelon matrix. The rank of matrix A is denoted as PA. To have a clearer understanding, let's look at the example given. I will explain on the example of echelon matrix first. To find the rank of a matrix is very simple. We only need to find how many rows in the matrix that is not entirely zero. For the first example, the matrix has 3 rows, and all of the rows is not entirely zero. Hence, the rank of the matrix is 3. For the second example, the matrix has 4 rows, and one of the rows is entirely zero. Hence, the rank of the matrix is 3. As for the third matrix, the matrix has 3 rows, but one of it is entirely zero. Hence, the rank of this matrix is 2. Next, we will go to the example for reduced echelon matrix. The first example, the matrix has 3 rows, but none of it is entirely zero. Hence, the rank of the matrix is 3. For the second example, the matrix has 4 rows, but one of it is entirely zero. Hence, the rank of the matrix is 3. For the third example, the matrix has 3 rows, but one of it is entirely zero. Hence, the rank of the third matrix is 2. Okay, that's all for my explanation, as well as for our group presentation. Thanks for watching.